Welcome to this training presentation on CEREC MTL Zirconia. CEREC MTL Zirconia is a CAD/CAM machinable zirconium dioxide all-ceramic for indirect restoration of teeth. This presentation aims at providing you with the most important facts which are the basis for your sales talk. CEREC MTL Zirconia is not the only new type CAD/CAM block in the Dentsply Sirona portfolio. So first, we will briefly discuss why Dentsply Sirona is introducing 3 different ceramic blocks. We will also shed some light on why Dentsply Sirona and Vita, the 2 renowned manufacturers of ceramic technology, have partnered up for CEREC MTL Zirconia. We will then talk about CEREC MTL Zirconia's strength, minimum wall thickness, and required milling tools. At this stage, you'll also hear something about the CEREC MTL Zirconia indications. After that, you will be informed about sintering and glaze firing aspects. We will also take a look into the aesthetic properties of the product, including touching on its multi-transitional layering technology. Finally, the luting procedure for CEREC MTL Zirconia will be briefly described. The presentation will be closed with a summary of CEREC MTL Zirconia, including a comparison to its key competitor, which is Katana from CEREC. All good things come in threes. In other words, in addition to CEREC Tessera and CEREC Zirconia Plus, CEREC MTL Zirconia is the third of the new chairside CAD/CAM blocks. The new CEREC MTL Zirconia block is the result of the development and distribution partnership between Dentsply Sirona and Vita, global players in dental ceramics technology. The main competitor to CEREC MTL Zirconia is the Katana CAD/CAM block from CEREC, which we are going to present briefly. All 3 blocks are part of the digital workflow. If you've seen the first 2 training videos on the ceramic blocks in the CEREC series, you'll already have an insight into CAD/CAM blocks. For example, that the Dentsply Sirona portfolio includes CEREC Tessera, a glass ceramic with state-of-the-art technology, exhibiting 700 megapascal biaxial strength, which is exceptionally high for this category of material. In addition, it is highly aesthetic and processed very quickly. Dentsply Sirona supplies CEREC Zirconia Plus with a high strength value of 1000 megapascal, enhanced translucency, and which is exceptionally good value for the money. CEREC Zirconia Plus supersedes CEREC Zirconia and the in-chorus range. CEREC MTL Zirconia is the third CAD/CAM version available. CEREC MTL Zirconia exhibits more than 850 megapascal strength, and when compared to CEREC Zirconia Plus, even further enhanced aesthetic properties. Both CEREC MTL Zirconia and CEREC Zirconia Plus are zirconium dioxide ceramics. Why so many blocks? From the distribution point of view, it is worth noting that half those dentists who work with CAD/CAM blocks use more than one type. 2 block offices typically use both a glass ceramic and zirconium oxide ceramic, according to indication. Why is that? Quite simple. Glass ceramics, such as CEREC Tessera, are popular for cases with demanding aesthetics, as their shades blend well with the residual tooth structure. Zirconium dioxide ceramics, which are slightly less aesthetic yet stronger than glass ceramics, are popular for use in the posterior region where aesthetics play a less significant role. In addition, they are exposed to higher masticatory forces there. CEREC Zirconia Plus and CEREC MTL Zirconia round off the Dentsply Sirona chairside CAD/CAM all-ceramic portfolio and help reach more dental offices. Like this, the client can choose between 3 blocks. Dentsply Sirona and Vita, 2 powerhouses in ceramic technology, partnered up to develop and exclusively commercialize CEREC MTL Zirconia, the next generation zirconium oxide CAD/CAM block. Vita is the designer and manufacturer of CEREC MTL Zirconia. It has set the standard in shade selection. Vita ceramic shades match Vita classical shade guides reliably. Dentsply Sirona is the inventor of the CEREC technology and has strong relationships with the CEREC community. The company owns the exclusive commercialization rights for CEREC MTL Zirconia. CEREC MTL Zirconia is a fourth-generation 4Y TZP zirconium oxide ceramic. This steel was made in heaven. CEREC MTL Zirconia is Dentsply Sirona digital workflow embedded. The first step in the procedure is scanning the preparation, for instance with a CEREC Prime Scan. The proven CEREC OmniCam, still among the smallest scanners on the market, is a viable alternative. CEREC Prime Mill is the grinding and milling unit that utilizes state-of-the-art technology to produce outstanding chairside restorations easier, faster, and more precisely than before. A modern setup for achieving predictable results. The in-lab CAD/CAM series can also be used. The CEREC Speedfire furnace sinters CEREC MTL Zirconia restorations within minutes to attain their final strength properties. The restoration can then be polished and glazed or polished only. CEREC MTL Zirconia can be processed with chairside Dentsply Sirona CAD/CAM devices, where CEREC software version 5.1.3 with material pack or higher is installed. The CEREC Prime Scan indicates automatically when a new version of the CEREC software is available. The following video illustrates briefly the process for fabricating a CEREC MTL Zirconia restoration. The first step is to select the block manufacturer, Dentsply Sirona, in the Restoration Type menu, followed by the brand CEREC MTL Zirconia. Acquire scans the prepared tooth, in this case the first upper left molar, and transfers the data to the processor. After defining the preparation margin, shown here in blue, the crown is designed. The virtual design of the restoration is then fitted into the digital model of the dental arc. The crown is then oriented within the block using the Manufacture menu. Thanks to the multi-transitional layering technology, the shade can be varied depending on the vertical position of the restoration in the block. We'll talk about this aspect in more detail later. With a global market share of 9%, Katana from Curaray is CEREC MTL Zirconia's main competitor. Of all the CAD/CAM dental ceramics, dentists use Ivoclar Vivadent's IPS Emax CAD the most. For such customers, CEREC Tessera CAD/CAM glass ceramic blocks from Dentsply Sirona are best positioned. Let's now take a closer look at the strength properties of CEREC MTL Zirconia. In the bridge fracture load test, specimens are exposed to a continuously increasing load until they break. The three-point bending test is also used to determine the strength of a material. Rod-shaped specimens on two support points are loaded until they break. Fracture toughness describes the resistance of a material against crack propagation. The tests mentioned above and the results influence the indications for and minimum wall thicknesses of restorations fabricated with CEREC MTL Zirconia. The bridge fracture load test involves producing a bridge-like specimen cemented to steel stumps and loading it until it breaks. In this test, CEREC MTL Zirconia was shown to have a loading capacity of 786 newtons, whereas Katana achieved 511 newtons. If you already know about dental ceramics, you'll be familiar with the 3-point bending test. It's shown again in the diagram on the right, just to remind you. With a 3-point bend of 857 megapascals, CEREC MTL Zirconia is one of the very few commercially available 4Y TZP dental chairside ceramics that exceeds the requirement of ISO 6872, which is 800 megapascals. The fracture toughness determined using the CNB method, according to ISO standard 24370, is 3.7 megapascals times the square root of a meter. The authors of the study conclude that CEREC MTL Zirconia performed significantly better than Katana STML. When fabricating restorations, slimline structures are often desired, particularly around the margins. During chairside CAD/CAM milling, these may fracture due to vibration. The high strength of CEREC MTL Zirconia allows for thinner walls, permitting less invasive restorations. For crowns, inlays, or onlays, the walls only need to be 0.6 millimeters thick. For veneers and the margins of single-unit crowns, wall thickness can be reduced to 0.5 millimeters. For the super-fast milling process, it is recommended to increase wall thickness of single-unit crowns to 0.7 millimeters. The necessary settings, especially for the super-fast milling process, are described in the following video. With anterior bridges, the walls must also be at least 0.6 millimeters thick, and the cross-section of the connectors 9 millimeters squared. For posterior bridges, the walls must be at least 0.7 millimeters thick, and the cross-section of the connectors 12 millimeters square. In comparison, Cure Katana requires much thicker walls of 0.8 or 1.0 millimeters and connector cross-sections of 12 or 16 millimeters squared for bridge work.
In this video, we would like to show you the workflow and recommended parameter settings to be observed in the CEREC software, especially in the case of the super fast milling mode. First, we will provide an overview of the minimum wall thickness for crowns in the anterior and the posterior region. For the milling modes, fine and extra fine, a minimal wall thickness of 0.5 respectively 0.6 millimeters, which is 500 respectively 600 micrometers, is required. However, for the milling mode superfast, it is recommended to increase the occlusal and radial minimal wall thickness to 0.7 millimeters, which is 700 micrometers. Detailed information about this topic is included in the CEREC MTL Zirconia instructions for use. We begin in the administration phase of the CEREC software. We are demonstrating a crown restoration on a first molar in the upper jaw, and we have already selected CEREC MTL Zirconia under Material in the Indications window. To switch to the acquisition phase, we tap Next at the bottom of the screen. For this type of restoration, at least one image catalog needs to be scanned. Since the prepared tooth is located in the upper jaw, the upper jaw image catalog is required, with both other catalogs being optional. As we will concentrate on the super fast milling mode in this tutorial, we will skip the scanning process, and you will see the finished scanned catalog next. Now, at the bottom of the screen, the little arrow to the right is displayed, indicating that we can move on to the next phase. As already mentioned, this tutorial focuses on the parameter settings. We therefore skip the model phase and go on with the design phase. The CEREC software automatically creates an initial design proposal, which we will first look at from different angles. In order to modify the minimal wall thickness, we switch back to the step Restoration Parameters. We are now in the local parameter settings, which means that changes made here are only applied to the currently selected restoration. In case of a crown restoration, it is recommended to increase 2 parameters, especially for the milling mode Superfast. To do this, we scroll a little further down. Parameters marked with a lock mean that these are manufacturer recommendations. As shown in the beginning, we will increase the corresponding parameters here. First, we click on the lock symbol for the parameter, minimal thickness, radial, which now allows us to correct the value to 700 micrometers, which is 0.7 millimeters. Next, the minimal wall thickness, occlusal, is adjusted accordingly. Then, both modifications are confirmed with OK. We switch back to the step Edit Restoration, and we check the new restoration proposal again. Now we continue with the last phase, the manufacture phase. In this phase, we can change the milling mode under manufacture. Beside fine and extra fine, you can mill CEREC MTL Zirconia, also with the Superfast mode. For transmitting the case to the prime mill, we click on Start.
Which burr is the best indicated depends on the milling unit in use. For further information, please refer to the instructions for the milling unit in use. Like all other zirconia ceramics, CEREC MTL Zirconia must be sintered. We're going to take a general look at which processes take place within ceramic materials such as CEREC MTL Zirconia during sintering. The shrinkage undergone by the coping is an important part of sintering, and you'll get some details on this too. At the end, the sinter and glaze firing times for CEREC MTL Zirconia will be shown. Sintering is the process of forming a solid mass of material by temperature difference without melting it. The heat rearranges the zirconium oxide component and fuses grains together. Let's take a closer look at this process. Prior to sintering, zirconium oxide ceramics are comprised of single, crystalline zirconium oxide grains. The scanning electron microscope image shows clearly that although the grains are compacted relatively densely, they are only bonded together weakly. In this state, the zirconium oxide restoration is often referred to as a green body. Through sintering, neighboring zirconium oxide grains are baked together, as can be seen in the lower picture. It is easy to imagine how this phenomenon increases the strength of the zirconium oxide ceramic. As sintering reduces the porosity, it also increases the density of the ceramic. Sintering is associated with remarkable shrinkage of the green body when exposed to heat. Competitors' zirconia oxide ceramics also undergo this shrinkage. The CEREC milling software takes the shrinkage into account. The restoration is automatically designed and milled accordingly larger. To ensure exact fit, it is therefore important to always scan the enlargement factor indicated on the block. The so-called Z code also denotes the shrinkage factor. Users who do not work with a Dentsply Sirona CEREC prime mill may also enter the Z factor into their milling device manually. The CEREC Speedfire is ideal for firing glass ceramics such as CEREC Tessera, but also for sintering zirconium oxide ceramics such as the CEREC MTL Zirconia. The table above indicates the sintering and glaze firing times for CEREC MTL Zirconia in a CEREC Speedfire. When firing single restorations with walls less than 4 mm thick, the sintering times may vary between 19 and 21 minutes depending on the tooth shade. By the way, restorations with the same shade may be sintered together. In general, glaze should be fired for 9 minutes. Rather than glaze firing, CEREC MTL Zirconia restorations may also simply be polished. Dentsply Sirona provides sintering programs for other furnaces, including those supplied by other manufacturers. The aesthetic properties of CEREC MTL Zirconia are particularly significant. In this context, we would like to briefly discuss how precisely dental shades can be matched to the Vita Classical Shade Guide. CEREC MTL Zirconia is based on the multi-transitional layering concept, which is also significant. The Vita Classical A1 to D4 Shade Guide has been available since 1952 and has established itself as the global standard. The Vita porcelain shades match those of Vita Classical Shade Guides accurately. Where CEREC MTL Zirconia is concerned, interaction between two aspects is decisive. Firstly, CEREC MTL Zirconia recreates Vita standard shades accurately. The dramatic shade deviation with porcelains from other manufacturers is shown here using Vita shade A3 as an example. This picture compares the shades resulting from using CEREC MTL Zirconia and Katana. It is quite clear that the A3 restoration fabricated with Katana is excessively reddish. The differences in the translucent, low chroma incisal region are only minimal, whereas those towards the cervical region are more significant. Secondly, the outstanding shade matching ability of CEREC MTL Zirconia is promoted by the multi-transitional layering technology. This comparison shows clearly that the shade of the CEREC MTL Zirconia crown on the left matches the Vita shade tab on the right, which demonstrates the excellent shade matching property of this product. The seamless shade gradient corresponds exactly with the Vita Classical Shade Guide. In this case, shade A2 was used. No sudden shade deviations with the crown are apparent. Thanks to its multi-transitional layering technology, CEREC MTL Zirconia exhibits no discernible shade layers, but rather a seamless shade gradient. A gradient is defined as the change in size over a certain distance. CEREC MTL Zirconia exhibits an extremely uniform shade gradient. Different layers, which may create the illusion of a sudden deviation in shade, are not visibly discernible. Consequently, the resulting CAD/CAM restorations also have a uniform shade gradient. During the digital design procedure, the restoration can be positioned as required within the block to create higher or lower shade intensity. When positioned on the lower edge of the block, the restoration appears slightly more reddish and chromatic, yet opaque, whereas on the upper edge it looks lighter and less chromatic or translucent. Positioning the restoration in the center of the block results in a shade closest to the Vita shade selected. The authors hope that this animation demonstrates this effect fairly clearly. By the way, please don't be concerned. The color of the block changes from white to the tooth shade during sintering. The last stage of treatment involves luting the restoration. Fundamentally, CEREC MTL Zirconia restorations can be luted adhesively, self-adhesively, or with a conventional water-based cement. Surface roughness enhances the bond between the tooth structure and restoration. We're also going to discuss briefly how to achieve this. Of the composite cements supplied by Dentsply Sirona, Calibra Ceram, together with Prime & Bond Active, Prime & Bond Universal, or Prime & Bond Elect, respectively, are indicated for this purpose. Calibra Universal may also be used. Please note that inlays, onlays, and veneers must be luted in full adhesive fashion. Except for inlays and onlays, CEREC MTL Zirconia restorations may be cemented with Calibra Bio from Dentsply Sirona. For further details regarding cementation, please see the instructions for use of respective products. Hydrofluoric acid is generally not effective in creating surface roughness on zirconium oxide intaglio restoration surfaces. To achieve surface roughness and hence increase bond strength, sandblasting with 50 micron alumina particles at 2 bar pressure is recommended. This is a schematic overview of the entire adhesive cementation procedure for CEREC MTL Zirconia using Calibre Ceram and Prime and Bond Active. The intaglio surface of the CEREC MTL Zirconia restoration has been sandblasted and hence roughened. The surface of the tooth structure is etched using phosphoric acid. The acid is rinsed off after a few seconds reaction time. Prime and Bond must then be applied to the tooth surface. The solvent of the adhesive is air-dried. The Prime and Bond layer must be light-cured after application, for instance with a SmartLight Pro, according to the instructions for use. The intaglio surface of the CEREC MTL Zirconia restoration is now coated with Calibre Ceram resin cement. Depending on restoration type, the tooth substance can also be covered with Calibre Ceram. The restoration is then placed in position. The cement can be tack cured for ease of excess removal. The restoration needs to be stabilized until end of setting time. We are approaching the end of this presentation. Now we're going to summarize the most important properties of CEREC MTL Zirconia again and compare them to Katana from CEREC. As it features multi-transitional layer technology, CEREC MTL Zirconia has no visible shade layers, but rather seamless shade gradients. There are no sudden changes in shade. CEREC MTL Zirconia is available in Vita shades A1 to A3.5, B2, C2, and D2. Its 3-point bending strength is as high as 850 megapascal. For crowns, inlays, or onlays, the walls only need to be 0.6 millimeters thick. With anterior bridges, the walls must also be at least 0.6 millimeters thick, and the cross-section of the connectors 9 millimeters squared. For posterior bridges, the walls must be at least 0.7 millimeters thick, and the cross-section of the connectors 12 millimeters square. It comes in 2 sizes, mono and medi. CEREC MTL Zirconia can be sintered in 18 to 21 minutes, depending on the shade. It can be luted using adhesive, self-adhesive, or conventional techniques. For the properties marked in blue, CEREC MTL Zirconia is on par with Katana from CEREC. All characteristics with an orange background are those where CEREC MTL Zirconia is superior to our competitor Katana. Your sales pitch should concentrate on these properties. We would like to remind you that the full sales and marketing collateral on CEREC MTL Zirconia, including this training presentation, is available on the Dentsply Sirona Sales Compass. The Sales Compass is available as a website and smartphone app. Please ask your manager how to get access to the Dentsply Sirona Sales Compass if you don't already have it. This is the end of the training presentation. Thank you for being so attentive. Dentsply Sirona would like to wish you all the best when selling CEREC MTL Zirconia.